All right, we're going to do problem number 4 on the free body diagram problems. And so here's the worksheet. It says a 50 kilogram crate is being pulled by 2 forces as shown in figure 2. And that's figure 2 right there, right next to it. There's no friction. What is the crate's acceleration? And B, what is the normal, oh, it should be the normal force on the crate. I'll have to fix that. What is the normal force on the crate? And so, oh, that's kind of, let's zoom out. Light off. All right. So, the first step of the procedure is to, you're given, find, and solve, and draw the picture of it. So they got given, and they've got the crate right here, and they show in the force, and the applied force here, and they listed those values very nicely right there. Well, we don't know the normal force yet, do we? That's what we're trying to find, is the acceleration and the normal force. We do know the mass is 50 kilograms, and this angle is 40 degrees. So that looks pretty good. Then the next step is to draw the free body diagram. Step 2. So here's the crate. We got an applied force, kind of got erased there a little bit, but we've got an applied force. We've got gravity. We've got the normal force, and then we have this applied force at this angle. And then step 3, draw your X and Y axes. They did that very nicely. And then look, this force and this force are lined up with the Y axis, but this force is at an angle of theta, 40 degrees actually. And so you have the X component and the Y component of that force, B. Okay, does that make sense to everybody? All right. So, we've drawn the free body diagram. We've divided up the force into their components. and so we're good. So now we can go on to step 4. We're going to sum the forces in the X direction and set that equal to MA in the X direction. So you look in the X direction, and there are 2 forces. There's FB cosine theta, which they put here, and then there's minus this other applied force here. Oh, that's F sub A. I'm sorry. That's F sub A. That's 10 newtons to the left. So I really like the way they laid this out there, and it actually cleared up my confusion. Here's F sub B is given to be 40 newtons times the cosine of 40 degrees. That's the X component. And then minus this 10 newtons equals, now this should say, oh, MA, then they divided by the mass over here, and that gives us the acceleration. And they got 0.412 meters per second squared. Y'all agree with that? Okay, it looks really good. Then you sum the forces in the Y direction. We do that because we're going to try to find the normal force. And so the normal force minus mg, but plus this component, this upward component. Look, that FB is lifting up on it. It's supporting some of the weight. So the normal force doesn't have to support all the weight. When you solve it for the normal force will be equal to the weight minus how much this is lifting up on it, on the crate. And when you do the arithmetic, you get 464. Look, this is kind of ridiculous. You don't know it to the nearest thousandth of a newton, people. I would say maybe 464.3 newtons. Okay, make sure you round off. Okay, so these answers look good to me. Any questions? Okay, very good. That is all.